Okay, so guys, I hope you're well. We are here to do some trig, right? Trigonometry specifically for grade 11. Okay, the first of this kind of video in 2026 because we haven't actually done any trig videos or any trig content so far. So let's go and let's also hopefully find some solace in doing so. So we're going to look at the very first question. The first question says, if negative 5 sine theta is equal to 4, and we are told that theta is an element of 90 to 270 degrees, determine without the use of a calculator and with the aid of a diagram the value of, and we are told the value of 5 cos theta minus 3 tan theta. So what do we do with these types of problems? We call these types of problems your Pythagoras type problems. Why do we call them your Pythagoras type? It's because we basically, in the process of trying to find the value of 5 cos theta, we use the Pythagorean theorem to be able to get the certain aspects. So our first thing that we do is we are supposed to use a diagram. How do we set up that diagram? So we take this trig ratio, which is negative 5 sine of theta, we equate it to 4. That's the first thing we do. Then we isolate the trig ratio. How? The coefficient of sine theta is negative 5. So what we do is we divide both sides by negative 5, and then that gives us sine of theta is equal to positive divided by negative is negative 4 over 5. So this here is the definition of sine in terms of numerical values. Sine of theta or theta is equal to negative 4 over 5. Then we ask ourselves, what is sine of theta as per your definition? It is opposite over hypotenuse. But in terms of x, y, and r on the Cartesian plane, what is the definition of sine? It is y over r. Okay, so then we are going to go to the Cartesian plane where we have our y and our x-axis. Okay, and just as a mini diagram of being able to wanting to locate where theta lies on our Cartesian plane, because we have our first quadrant, our second quadrant, our third quadrant, and our fourth quadrant. In these quadrants respectively, we say that in the first all trig ratios are positive. In the second quadrant, we say it is only sine and its reciprocal cosec that are positive. In the third quadrant, we say it's tan only that is positive and all other trig ratios are negative. And here cos is positive and all other trig ratios are negative. So our first question is, where is sine of theta negative? Why are we asking where is sine of theta negative? It's because the ratio 4 over 5 is negative, which implies that sine of theta is negative. So we are asking ourselves, where is sine of theta negative? So according to the ASTC rule, where is sine negative? Is it negative in the first quadrant? No. All trig ratios are positive. Is it negative in the second quadrant? No. Sine is positive in the second quadrant. Is sine negative in the third quadrant? Yes, because only tan and cot are positive in this quadrant. Is it negative in the fourth quadrant? Is sine negative in the fourth quadrant? Yes, because sine is negative in the fourth quadrant. So we have to then agree that it is in the third and the fourth quadrant that sine is negative. So so far we have ticked in 2 quadrants where sign is negative. Additionally, we are told that theta is an element of 90 to 270. What this means is theta is an element of 90 to 270. That means that theta lies between the 90 and 270 degrees. Now on your Cartesian plane, we have 0 degrees there, 90 here, 180 here, 270 there, and then back at 360, which is an entire revolution. Okay, so that's where our unit circle exists. Now, that being the case, 90 to 270, which quadrants are 90 and 270? Between 90 and 270 is the second and the third quadrant. So we are going to take the second and the third quadrant. Now I'm sure you guys can see that on our Cartesian plane, the quadrant that has the most number of ticks is the third quadrant. That means our terminal arm will be located here in the third quadrant. We then complete a 90-degree angle triangle using our terminal arm. Then we define what sine is for this right angle triangle. This is x, this is r, and this is y. Why is this x? Because on the x-axis our x values are found. Why is this y? Because it is parallel to the y-axis. Why is this r? Because this is the hypotenuse side, which is always opposite 90 degrees. Now guys, r is always positive. Always positive for any diagram. R is always positive. We need to always remember that R is forever and always positive. Hi Brandon, how are you doing and where are you from, my dear? Which beautiful country do you hail and reign from? And which standard or grade are you in, if you are in a particular standard or grade? So R is always positive. Okay, why? Now, according to sine theta, the definition, we said sine theta is y over r. So in this quadrant, the y value is what? 4. But is it 4 that is positive or is it 4 that is negative? It's 4 that is negative because our y value here in this quadrant are negative values. Your y values here are negative below the x-axis. R on the other hand, which is basically your 5, is positive because we did say that r, the hypotenuse, is always a positive value. Now we need the value of x to complete our right angle triangle. What do we use? To find x, we use Pythagoras. So then we're going to say the square of the hypotenuse side, which is r, is equal to the sum of the square of the other two sides. That, guys, is the theorem of Pythagoras. R is 5, so it's 5 squared. X, we don't know yet, we're trying to find that. Y, -4, -4 squared. Then what's 5 squared? 5 squared is 25. What's -4 squared? It is 16. Okay, then we want to isolate x and solve for x. So we take the 16 over. When we transpose the 16, it becomes -16. We isolate x squared. Then that's 25 minus 16. That gives us 9. That means x squared is equal to 9. We take the square root of x on the left, but what we do on the left, we do on the right. And for the numerical value, guys, we always in an equation will put plus minus to indicate that our values of x can be one of two values. It can either be a positive value or a negative value. The square root of 9 is 3, so that means our value of x can either be positive or negative. Now, in order to determine whether the value of x is positive or negative, we go back to our diagram. In the fourth quadrant, guys, the value of x, is it a positive value or is the value of x a negative value? That's where I want to ask the question. Is the value of x in this quadrant for this triangle a negative value or is it a positive value? You really don't know this. It's nako konke dube. Okay, so I just started this. So you can know this if you want to. You just need to give yourself a chance to know it. Okay, so are you willing for me to go back and re-explain so that you can understand, or do you want to remain not understanding? Okay, so you let me know in the comment section. In the value of x here is going to definitely be what? Be negative. Okay, so we conclude therefore x is equal to negative 3. We choose the negative value, we reject the positive value because in this quadrant x is negative 3. Okay, theta, okay, is the angle defined there. Then of course we can also determine the third angle, which is this one, which will be 90 minus theta. So we have theta, we have 90, 90 minus theta. You add those angles together, you will get 180. Minus theta plus theta will give you 0, and then the 90 plus 90 gives you 180. So the entire triangle, you can actually then use this triangle to be able to determine certain values. So now, moving right along, we are going to go ahead and determine the value of, because remember they wanted us to find the value of 5 cos theta minus 3 tan theta and the value of 4 over sine theta minus 3 over cos theta without having to use the calculator with the aid of the diagram. The diagram we now have, hello Tloghi, hello Sekhametse, good to see you guys. So now that we have a complete right angle triangle in the right quadrant, having laid the foundation, we can now go ahead and do what? We can go ahead and find the value of 5 cos theta minus 3 tan theta. So we write the expression, then cos theta. We go to our diagram and we ask, what is cos theta? Cos theta is adjacent over hypotenuse, meaning x over r. So it's negative 3 over 5. In the place of cos theta, we substitute negative 3 over 5. Do you see that? Cos theta gets replaced with negative 3 over 5. Minus 3 tan. What is the definition of tan using the triangle? Tan is opposite over adjacent. So it's negative 4 over negative 3. Negative 4 over negative 3. Okay. Then we simplify. Don't forget BODMAS. Okay, when we are here, positive times a negative, the 5 and the 5 cancel. I'm left with negative 3. Because this is in the numerator, this is in the denominator. 5 divided by 5 is 1. 1 times negative 3 is negative 3. Then again here, negative times negative divided by negative. So a negative divided by negative is positive. The negative times the positive gives us a negative. Then 3 and the 3 cancel out. 3 divided by 3 is 1. We are left with 4. Okay, 1 times 4 gives us negative 4. Minus 3 minus 4 is negative 7. Guys, this is the value of 5 cos theta minus 3 tan theta. It is negative 7. And all I did was use this triangle to replace cos theta and tan theta with the appropriate numerical ratio, and then I simplify using Mr. Bodmer's. And that's that. Okay. That was number 1 of the first question. Number 2 said the value of 4 over sine theta minus 3 cos theta. So I do the same thing. I replace the sine and the cos with my ratio read from the triangle. Okay, I replace my sine and my cos with the ratio that is read from the right angle triangle that I set up in the third quadrant. So I'm going to say 4 over, what is sine theta? Sine theta is opposite y over r, opposite over hypotenuse, so it's negative 4 over 5. Minus, what is cos theta? The 3 is there. What is cos theta? Adjacent, meaning negative 3 over hypotenuse. So it is negative 3 over 5. Then 4 divided by negative 4 over 5. That is 4 divided by negative 4 over 5, which is the same thing as 4 times. We play the KFC rule. 4 times negative 5 over 4 minus 3 divided by, that's 3 over 1 divided by negative 3 over 5. KFC as well here. I mean KCF, we keep the number, we change the sign, we flip the fraction. Okay guys, these are separate like this because remember Bodmer says we start with division, subtraction later, division first, then subtraction later. So we focus on the division, okay, and then we change the divide to multiply, because remember this is 4 divided by negative 4 over 5. So it's 4 divided by negative 4 over 5, which is 4 times. We change the fraction, we flip the fraction, negative 5 over 4. This 4 and this 4, 4 divided by 4 is 1. 1 times negative 5 is a negative 5 minus, same thing here, 3 divided by 3 is 1. 1 times negative 5, we get another negative 5. Okay, so then this is like negative 5. Negative times a negative is positive 5. Yes, we get a beautiful 0, which is our final answer for the trigonometric Pythagorean approach of solving for our question. So guys, this first question was basic and simple. You isolate the trig ratio, you form a ratio of sine theta is negative 4 over 5. From this, you say sine is what? This negative sign means sine is negative. Then you ask yourself, where is sine negative? You tick the quadrants. Sine is negative in the third and the fourth quadrant. Your first ticks 1, 2. Then you have another restrictive sort of like restriction where they are saying theta is an element of 90 to 270. In other words, theta lies between 90 degrees and 270. What does that mean? In the Cartesian plane, 0, 90, 180, 270, and 360 are on the Cartesian plane. So to say theta lies between 90 degrees and 270 means 90 to 270 is the second and the third quadrant. So I have 2 ticks now in the third quadrant. That means that's where theta, my acute angle, is going to lie. Theta is going to lie here in the third quadrant. So I draw my terminal arm, I complete the right angle triangle, and then after that, I then assign my sides using the trig ratio sign. Sine theta is opposite over hypotenuse. That means y over r. Negative 4 is my y value. Positive 5 is my r value. Because remember, on this Cartesian plane, r is always positive. So the reason why I know that y is going to be negative is because in this quadrant, the y value is negative. In this quadrant, my r value will be 5. Now I have to find this third side. So what do I use? I find x using Pythagoras. So I use Pythagoras. I said the square of the hypotenuse side. Remember, the hypotenuse is actually the side that is opposite your 90 degrees, is equal to the sum of the square of the other two sides. So x squared plus y squared. Write the reason Pythagoras. You substitute in the place of r 5 squared, x squared, that's what you want to find. Y, you substitute -4 and you square it. Then you solve, guys, for x. 5 squared is 25. -4 is 16. You take the 16 over, it's 25 minus 16, which is equal to x squared. 25 minus 16 is 9. To find the value of x, you take the square root on the right. What you do on the right, you do on the left. When you take the square root for the numerical value, you basically then are able to get plus minus 3. That's the x value. Then your specific value of x in this quadrant, remember your x values this side are negative. So now we are going to select the negative value and reject the positive value. That's why we conclude and you say therefore x is equal to -3. Then our triangle has all sides x, y, and r. Angles, this is theta, 90. Then obviously angles of a triangle add up to 180. So in order for us to define this third angle, we know that this third angle will be 90 minus theta. That's theta, that's 90 minus theta, that's 90. All sides and angles are defined. Our triangle is complete. We can now find the specific values of the given trig expressions. And what do? We use this triangle, substitute in the place of cos and tan, and then simplify to get the answers that I had explained we get here. Okay. Let me do one more Pythagoras type, and then I'm going to move on to another. Okay, let's look at this one. This one, if 2 cos alpha plus 1 is equal to 0 and sine alpha is less than 0, determine without the use of a calculator and with the aid of a diagram the value of. Okay, so let's do the same thing. Take the trig ratio, the equation, isolate cos, and get the trig ratio for cos. So what does it say? 2 cos alpha plus 1 is equal to 0. Cos alpha is equal to -1. Then we divide both sides by 2. That means cos alpha is equal to -1 over 2. That's step 1. Step 1 has been completed. Then let's define this thing. What is cos by definition? Adjacent over hypotenuse, which basically in the Cartesian plane, that is x over r. Cos is negative. Where is cos negative? Okay, so if you know your ASTC, you know that cos is negative in the second and in the third quadrant. Okay, second and the third quadrant. Then there's an additional restriction furthermore that says sine of alpha is less than 0. What does sine of alpha less than 0 mean? Let's interpret that. When they say sine of alpha is less than 0, that's a restrictive measure that is saying sine of alpha is less than 0 means that sine is negative. So the question then is, where is sine negative? Sine is negative in the third and the fourth quadrant. So once again, you can see, guys, where do we have the most amount of ticks? It's in the third quadrant. So our diagram is going to fall in the third quadrant again. So we draw our terminal arm. Okay. Sorry about that. Draw our terminal arm. We complete our right angle triangle using that terminal arm. Then we come here, x over r. Negative half is x over r. So where is x? X is here. That means 1, which is negative, is going to be my x value. R being always positive means r is going to be 2. How do I find y? Obviously, to find y, we're going to use who? Pythagoras. So the square of the hypotenuse is equal to the sum of the square of the other two sides. Then r, that's 2, we square it. X, that is basically negative 1, we square it. Y squared, y is y. 2 squared is 4, negative 1 is 1, plus y squared. We transpose. 4 minus 1 is equal to y squared, that is 3. We take the square root on both sides. Guys, if you can, do share the live with your mates. Doesn't matter where they are. Share the live with your mates if it's possible. Plus minus, okay? Then that means y is equal to positive and negative 3. But given where the diagram is, Cartesian plane is on the third quadrant, y here is negative, so we know that's going to be a negative square root of 3. Y is equal to a negative, okay, square root of 3, not the positive one. So we reject the positive value, we accept the negative. This is theta. That's going to be 90 minus theta. Me, I love completing my right angle triangle, the theta value as well as the 90 minus theta. So all angles and all sides, I love when my Cartesian plane has all sides, all angles. I know they are defined, all of them. Okay? Yeah. All are defined. All are defined, guys, which is very nice. I particularly enjoy knowing that everything is defined. Okay, sorry, that's alpha, not theta. So I supposed to say 90 minus alpha and alpha, okay? Because we are dealing with alpha, not theta. You say I'm so used to theta, but it's alpha, guys. Then the question says, determine using the diagram tan alpha minus sine alpha. So I'm going to say tan of alpha minus sine alpha. Now we just play replace. Guys, we replace trig ratios with numerical fractions. So tan alpha, we go to the diagram. What's tan of alpha? That's opposite over adjacent. So that's negative root 3 over negative 1. Negative root 3 over negative 1. Minus sine of alpha. What's sine of alpha? Sine of alpha is opposite over hypotenuse. So in brackets, negative root 3 over 2. Then we simplify. Negative divided by negative, that's positive, so that's root 3. Negative times a negative, that's positive root 3 over 2. Okay. And then, guys, really at this point, you can go ahead and use your calculator, to be honest. They say without using a calculator, but that does not mean at this step, if you want just to quickly go ahead and get the answer, you can't use a calculator. So it's root 3 plus root 3 over 2. Yeah, which is 3 root 3 over 2, the answer. Well, you can quickly do that. Okay. You will not be penalized, because the whole thing of using a calculator does not necessarily mean that you can't use a calculator. It's just that they want to see your steps, the diagram being drawn, finding the y values, substituting, simplification, proper simplification. And I mean, of course, I know some people would insist, on using the LCD, which is fine, okay? For both fractions, LCD, you form equivalent fractions, okay? That 2 root 3 over 2 plus 3 root 3 over 2, that would be your equivalent fractions. When the denominators are the same, you can go ahead and add the numerators. Remember, 2 root 3 plus 1 root 3, we treat these like terms. You keep the root 3, you add the coefficients. 2 plus 1 is 3. So that's why you get 3 root 3 over 2 as your final answer. Okay, that's one. And then the second one says 2 sine squared alpha minus cos squared alpha. I'm glad that disappeared because we need to understand that 2 sine of alpha squared minus cos alpha squared. You rewrite this. This is the square of the trig ratio. So 2 is isolated. You just put it outside. The square applies to the trig ratio alone. Same thing here. The square applies to the trig ratio, not to the sine. So the coefficient is not affected when you apply the exponent to the trig ratio. The coefficient 2 is not affected. So this 2, go to your diagram, sine is opposite over hypotenuse. So that's negative root 3 over 2. You square that alone. Minus cos alpha. Cos is adjacent over hypotenuse. So that's negative 1 over 2. You square that. So BODMAS says brackets first, then your exponents. Orders means exponents. So you apply your exponent 2 to negative. That's 3. That's exponent to the sine. That's positive. Apply the square to root 3. It's 3 over 4 minus even exponent to a negative sign is positive 1 over 4. Then 2 times 3 is basically 2 times 3 over 4. That gives you what? 3 over 2 minus 1 over 4. Then you normal see the LCD is 4 for both. You times by 2 here, you times by 2 at the top. That's 6 minus 1, which gives you 5 over 4 as your answer. Okay. Yeah, guys, that's basically how you simplify using your Pythagoras type. Okay. Yeah. Okay, let's turn our attention to something else. So the trig Pythagoras type, we looked at 2 fundamental questions that are really nice. Hopefully those are really nice and we can see how easy that is. Let's look at some function and co-function value questions. Function values and co-function values. Questions together with negative angles and angles greater than 360. Okay, so that we can see how we are able to easily simplify. Sine of 360 minus alpha times sine of 180 plus alpha. Simplify this. So these are function values, and we know that with function values, Mr. CAST needs to be very close by, but also we need to understand that this is 180 minus, this is 180 plus, this is 360 minus. Okay, so very important, right? These are basically, your unknowns are considered as acute angles. So what's sine of 360 minus alpha? Okay, when you do these questions, you ask yourself, 360 minus alpha is in which quadrant? It is in the 4th quadrant. How is sine in that quadrant? It is negative. So you write negative sine, and then you take the acute angle. Negative sine alpha is your answer. Times the relationship is multiplied. So when the relationship is multiplied, I love putting things in brackets. Same thing, what's sine of 180 plus alpha? 180 plus alpha is in the 3rd quadrant. How is sine in that quadrant? Sine in that quadrant is obviously negative because only tan is positive here. So we have negative sine of alpha. So now you getting these 1 mark each, then you multiply. Negative times a negative is positive, and then sine times sine is going to give you sine squared alpha. That's us simplifying to become a basic trig ratio. The answer is sine squared alpha. Okay, hopefully you see that and how it works nicely there. Sine 180 minus b times tan 360 minus b over sine 180 degrees plus b. What about this one? Okay, once again we have a relationship. Here the relationship was just multiply. Here the relationship is multiply and divide. Okay, so we are going to also reduce, okay, our function values. Okay, reduction. This we call reduction. This is all reduction. Reducing to a single trigonometric ratio. 180 minus is in which quadrant? It is in the second quadrant. How is sine there? Sine is positive, so it's positive sine b. Tan 360 minus b. 360 minus is in the fourth quadrant. How is tan there? Tan is negative, so we say negative tan b. Okay, negative tan b. 360 minus is in the fourth quadrant. In the fourth quadrant, tan is negative, so we say negative the trig ratio and the acute angle. Sine 180 plus b, guys. 180 plus b is in which quadrant? 180 plus is in the third quadrant. How is sine in the third quadrant? Sine in the third quadrant is going to be what, guys? Yes, exactly. Thank you, Zephamet. It's going to be negative, so we have negative sine b. Now that we have all of this, simple, guys, we can cancel. Sine divided by sine, positive divided by negative. Obviously, we are going to have a negative tan b over negative 1. Okay, yeah, because when you cancel, we are left with 1 and 1. Then a negative divided by negative is going to give you a positive. So we've simplified to a single trigonometric ratio, which is the goal, and the answer is tan b. Okay. Sine squared 360 minus theta cos squared 360 minus theta over sine 180 degrees plus theta times sine 180 degrees minus theta. Okay, let's go. Sine squared 360 minus theta. Okay, so what I like doing personally is the following. Because these are squares, I love taking out the square so that you guys can see why it is that eventually we can write down this shortcut. Because you see, the thing is, when you evaluate this, you know that what's going to come out of it is going to be a positive answer. Okay, because you have an even exponent. An even exponent applied to a negative or positive sign will always result in a positive answer. But if there was an odd exponent, when you apply it to a negative sign, it leads to a negative answer. Alright, so that's something you need to be aware of. So sine of 360 minus theta, we are squaring. We are going to eventually square whatever we get inside of here, which is why whatever we get is going to be positive. But let's look at it step by step. Sine 360 minus theta is in the fourth quadrant. How is sine there? Sine is negative, but then you are going to square it. Cos 360 minus theta is in the fourth quadrant. 360 minus theta is in the fourth quadrant. How is cos there? Cos is positive, but you are eventually going to square it. Here we're not going to square anything. Just evaluate 180 plus theta, third quadrant. How is sine? Sine is negative. And then of course, last but not least, sine of 180 minus theta. 180 minus theta is in which quadrant? It is in the second. How is sine? Sine is positive. When I apply the square to the negative sign, it is sine squared theta cos squared theta. Negative sine theta obviously stays, and then the sine theta at the bottom also stays. So I have sine squared theta times cos squared theta at the bottom. Negative sine theta times sine theta gives me negative sine squared theta. So I'm sure you guys can see that these two cancel out, but a positive divided by negative gives you a negative. Okay, positive times positive is positive times negative is negative. So final answer, we have cos squared theta over negative 1. You divide both, you get negative cos squared theta. Okay. So by doing this, I'm trying to explain. Okay. Now, in a typical exam, someone can move from this step directly to this one. All of these are just me trying to reveal so that the explanation of why we have a positive sine squared theta is clear to you. But in an exam, a person can move from here directly to this step. From here directly to this step. Does that make sense? You can move from here directly to this step. Right? You can move from there directly to this step. So all of these can be skipped. And then of course you evaluate sine 180 plus theta, you can get negative sine theta. You evaluate that, you get positive sine theta. And then it's like 1, 2, 3, 4. And that's basically you get to that. So I was just trying to explain by doing the step by step. I wanted you to see why it is that even though we evaluate sine of 360 minus theta and we get a negative sine theta, applying that square, which obviously you understand is outside the trig ratio, makes the trig ratio eventually positive because your exponent is even. Okay, right. I hope we are together there and that it's clear as daylight. Okay, simplify. Cos of 90 plus theta and sine of negative theta. Okay. So this exposes us to the world of cofunctions firstly, because cofunctions 90 plus or minus or 270 plus and minus, this is where cos changes to sine and sine changes to cos, vice versa. Okay, so whenever you have a 90 plus minus or 270 plus or minus, the trig ratio changes. Okay, cos changes to sine, sine changes to cos. So if we are evaluating cos of 90 plus theta, the first question we ask, 90 plus theta is in which quadrant? Obviously in the second. Okay, 90, so for cofunctions we have 90 plus, 90 minus, 270 minus, and 270 plus. That's where obviously trig ratios change. Cos changes to sine, sine changes to cos. So cos of 90 plus theta, which quadrant is that? Second quadrant. How is cos? Cos is negative, but then we write the reciprocal, we write the cofunction. The cofunction of cos is sine. So it's negative sine theta over then here we have what we call negative angles. The way I deal with negative angles is I add 360 two negative angles. I add 360 until we are between the 0 to 360 interval. Okay, so if we add 360 to minus theta, what does that become? It becomes sine of 360 minus theta. So in your head, you are actually saying 360 minus theta is in which quadrant? Obviously, that's in the fourth quadrant. How is sine in the fourth quadrant? Sine is negative. Okay. So it's key to add 360. Now 360 minus theta falls within the 0 to 360 interval. So adding 360 the first time makes it such that we know which quadrant is this angle in. It's in the fourth quadrant. So we have that. Negative divided by negative is positive. Sine divided by sine is 1. So our answer is positive 1. Okay. So co-functions, not a problem, guys. Shouldn't be. Okay. 5. Okay. Okay. Now we have angles that are greater than 360. Angles that are greater than 360. So what do we do with those? Angles that are greater than 360, we subtract 360 from them until we fall in the 0 to 360 interval. So 720 degrees is definitely way above 360. So what we do is we grab our calculator. 720, we subtract 360 the first time, we get 360. So that's like now saying 360 minus alpha. That falls within the 0 to 360 interval. We are safe. Tan, this is a negative angle. We add 360. So if we add 360, we are going to say 360. We add it. That's going to be minus that angle. We are also in the 0 to 360 interval. We are safe. This is 720 again. We subtract 360. We get sine of 360 plus alpha. That's still outside the 0 to 360 interval. We subtract 360 again. We get sine of alpha. Okay, which is safe. I hope you understand here. We subtracted 360 the first time. We get 360 plus. That 360 plus, guys, is not within the 0 to 360 interval. 360 plus is beyond the 0 to 360 interval. So I subtract 360 the second time. So after subtracting 360 the first time, I subtract 360 again. I get 0. So that means I can just now write 0 plus alpha, which is basically alpha. So that's why my answer is sine alpha. Okay, then tan 360 minus alpha. This one is fine. Okay, now we can evaluate sine of 360 minus alpha confidently and sweetly. 360 minus alpha is in which quadrant, guys? This one. 360 minus alpha is in which quadrant? It is in the fourth quadrant. How is sine there? Sine is negative. 360 minus alpha is in which quadrant? It's in the fourth quadrant. How is tan there? Before I answer, let me just check. How is tan in the fourth quadrant? Definitely it's negative. Don't forget the acute angle. Sine of alpha is obviously sine of alpha. 360 minus alpha, so once again we have the same situation there. Now we can do cancellation. We can cancel because here the relationship between the trig ratios is multiply and divide. There's no addition or subtraction sign between separation of terms. Does that make sense? So this and that they go, that and that they go, but your negative times a negative is a positive, times another divided by another positive is a positive, times a negative is a negative. So for your final answer is negative 1. Because you're left with 1, that's negative. You're left with 1 there, 1, 1. So that basically leads to a answer of negative 1. Well understood, I'm glad. Well, I'm glad. Okay, so here's another one. Relationship is multiply and divide, no additional subtraction between the terms, which is great. So that means we are going to just simplify and eventually get to our answer. So tan squared of x minus 180. What do we have here? This is a negative angle because 180 is negative. So what do? We add 360. When we add 360, this tan becomes, if you add 360, you get positive 180. So that's like 180 degrees plus x now. Okay, but most we know this we are going to evaluate and then square. Sine 540 minus x, this is an angle greater than 360. So what do? We subtract 360. We're going to subtract 360 until we fall into the 0 to 360 interval. We subtract 360, we get 180. So this is the same thing as sine of 180 minus x. Thank you. Over. This is fine. Sine of 180 minus x. And then this here is a negative angle, negative 360. So what do? We add 360 to what? To negative 360. Okay, and what do we get? We get a negative angle. We still get negative x because this is going to be negative x plus 0. So we add 360 again. When we add 360 the second time round, now we have tan of 360 minus x. This is falling within the interval of 0 to 360 that we want, so that we can now apply the reduction of the trigonometric ratio to its acute angle. So tan of 180 plus x, remember this I'm doing step by step just for the purpose of explanation so that people understand. But like I said, you can jump from this step directly to this, and then you can just, you know that there's going to be a positive answer that's going to come out when you apply the square. But I'm going to show step by step so that you understand. Tan of 180 plus x, when you evaluate that, 180 plus is in the third quadrant. How is tan? It's positive. So you know almost a positive tan x, you square that, it becomes tan squared x directly. Okay. Sine of 180 minus x, 180 minus is in the second quadrant. How is sine? Sine is positive. So that becomes sine of x over 180 minus x, same as that one. Positive sine x. Then last but not least, tan of 360 minus x. Fourth quadrant, tan is negative. So negative tan x. Cancellation can happen because it's not a cross and addition or a subtraction sign. We cancel there. Remember, there's a negative sign. So our answer is eventually going to be negative. Tan, there's one tan that is left at the top. So that means our answer is going to be tan x, negative tan x, because the tan x divided by, remember there's a 1 there that is negative that is left. Tan x divided by negative 1 will give us a negative tan x, which is our final answer. Okay? Reduction, guys. Reduction. You see? Please, man. Like, I mean, I mean, yeah, trig is such an ABC game. Okay, you understand the basics, then you can fly very nicely in trig. Okay. Okay. So this time round, multiplication plus, so that means we have addition now in the numerator, but there's multiplication of 2 at the bottom. We have 1 trig ratio. Let's evaluate tan 180 plus. We're just looking to see, okay, okay, let's first write tan 180 plus theta sine of 360 plus theta. Remember, tan of 360 plus theta, that means we subtract 360. Okay, yeah, we're just trying to prepare the soil here. This is 360 plus theta. It's more than 360. So when what do? We subtract 360, we get sine of theta. Okay, sine of theta plus 360 minus, okay, that's within the 0 to 360 interval. That's fine. That's a negative angle. Remember, we add 360 here, so we're going to have 360 minus theta. Okay, so we know we're operating from the 4th quadrant there, and then here it's tan of 180 degrees minus theta. Okay, so let's now reduce 180 plus theta. We can now reduce using our Cartesian there. 180 plus is in which quadrant? 3rd. How is tan? Positive, so we have tan theta. 1 mark already. We have 1 mark there already, that's sine theta, which is great. Plus, here we reduce, we have what? 360 minus is in the 4th quadrant. How is sine? Negative, guys. Tan 360 minus theta, 4th quadrant. How is tan? Tan is also negative there. We have negative tan theta. That's a multiplication of 2 negative signs over tan 180 minus theta, 2nd quadrant. How is tan there? Negative. Guys, these evaluations, these are marks, guys. That's where, I mean, you can't mess up. Messing up here, guys, leads to loss of marks. You can't be losing marks with reduction, man. 100%. This thing should be done 100%. No joke. Okay, so now let's tan times sine theta. That's basically tan theta sine theta. Okay, and then negative times the negative, that's positive. So that's sine theta tan theta as well. So it's plus sine theta tan theta over what? Over tan negative tan theta. So if you think about it, these here at the top are like terms. Tan theta sine theta plus sine theta tan theta. These are like terms. So it's like me saying tan theta sine theta plus tan theta sine theta. You have how many tan theta sine thetas? You have 2 tan theta sine theta, which is all over negative tan theta. Now cancellation can happen. This guy and this guy cancel. We're left with 2 sine theta over negative 1. And that positive divided by negative gives you negative 2 sine theta. 1 trigonometric ratio simplified to not a problem. Okay. Yeah. Guys, I think we get the point, right? I think we get the point very well. I think we get the point very well. let's ask you, I'm asking you. No. Remember, there was a clear first term plus second term. Okay, there's a plus sign that separates terms. So tan theta, I got 180 plus theta is positive tan theta. This sine theta times sine theta, there's a plus sign that separates. So we have two terms this time round in the numerator. Okay, a multiplication of these two with the multiplication of these two. Yeah, there was a plus sign. Okay, so there were two terms in the numerator, unlike all the other problems where there was one term all the time. Okay, yeah, so be careful there. Okay, look at these types of problems without the use of the calculator. Okay, these types of problems. But just before that, there are these Pythagoras type problems that we need to also be mindful of. Okay, yeah, so I'm just gonna select one of each. So let's come here. Okay, and that's sine of 300 degrees times the cos of negative 395 degrees minus cos of 210 degrees times the sine of 235 degrees all over, let's do the number n, tan of 150 degrees times sine of 775 degrees plus cos of negative 30 degrees and times the cos of 250 degrees. Okay, just so that we can touch upon different types of problems with trig. I don't want to focus on one and we miss out on others. So basically here we have numerical angles that are numerical values. So you can see at the top we have 1, because that's multiplication, minus, so two terms at the top, two terms at the bottom. So the whole purpose is to reduce all angles to acute angles. What do we mean by acute angles? Acute angles are angles that are between 0 and 90 degrees. So sine of 300, we need to reduce that using our function values. 180 minus 180 plus 360 minus. And maybe in certain cases where we can see that it is viable, we can use 90 minus, but this 90 minus, 90 plus, and 270 minus and 270 plus, we actually use as a last resort. Okay, we primarily want to focus on function values where trig ratios don't change. So sine of 300, we can say sine of what? Sine of what? Sine of 360 minus 60. Okay, so the function value with an acute angle, and this acute angle is a special angle. Okay, we have what we call special angles, 30 degrees, 45 and 60 are special angles. All right, so 360 minus 60 gives you 300. Okay, so use the function value with the appropriate acute angle for reduction. Negative 395, this is a negative angle. So what do we do with negative angles? We add 360. So I'm going to say negative 395, add 360, we get negative 35. But remember, negative angles as well, we need to add 360 again. We add 360 the second time, we get 325. So cos of 325 is better. Okay, minus cos 210, let's reduce that one, 180 plus 30. Okay, special angle. Sine 235. Okay, sine of 180. Now 235 minus 180, that gives us 55. So I'm saying 180 minus 55, that's an acute angle. Not necessarily special, but it's okay. Over tan 180 minus 30, that gives me 150. So 180 minus 30, that's an acute angle. Sine 775. This is an angle greater than 360. So what I do, grab my calculator. I'm like 775. Let's subtract 360 the first time and check. Does our angle fall between the 0 to 360 interval? No. So I'm going to subtract 360 again. Does my angle now fall between the 0 to 360 interval? Yes. And what's even better is that it's acute. So that means I don't even have to reduce that one. I can just write sine 775 as sine 55. Okay. Plus negative angle. This is cos of negative 30. So I just say 360 minus 30, because it was negative 30. That gives me cos of 330. The angle is between 0 and 360. Cos 215 I can reduce. Cos of 180 plus what? Okay. What's 215 minus 180? Gives me 35. So I can say 35. Okay. Alright. So let's proceed now. Let's reduce. What's 360 minus? Which quadrant is 360 minus in? It is in the fourth quadrant. How is sine? Negative. Cos 325. 360 minus 35. We can use that. Reduce cos 180 plus 30. 180 plus is in which quadrant? It's in the third quadrant. How is cos? Cos is in the third quadrant. Cos is exactly 180 minus 55. It's 180 minus is in the second quadrant. How is sine? Sine is positive. Okay. Because there's no 90 plus or 270, I'm not worrying about the change in the trig ratio. That's why I say we first bend towards our function values, 180 plus 180 minus and 360 minus. 180 minus 30 degrees. 180 minus 30 is in the second. How is tan there? Sine 55, we are sorted, that's fine. Cos 330, let us reduce that. Cos of 360 minus 30 degrees. Then cos 180 plus 35. 180 plus 35, guys, is in the third quadrant. How is cos there? Cos is negative. So for now, we have negative sine 60. Let's reduce this one. Cos 360 minus. 360 minus is in the fourth quadrant. How is cos? Cos is positive. Negative times a negative, that's positive. So that's positive cos 30. Sine 55. All over negative tan 30. Sine 55. Reduce cos 360 minus 30. 360 minus is in the fourth quadrant, right? 360 minus is in the fourth quadrant. How is cos in the fourth quadrant? Positive. So we have that positive sign here, but cos 30, and then that negative, okay, that negative sign. Okay. So things are looking okay so far, right? But now we just need to sort out our signs in between, so that our signs in between reflect. What needs to be reflected? Yeah. So there's something you need to note here. Okay. So there's this thing that we call the complementary co-function or co-ratio. Complementary means when things add up to 90. Co-function, cos being sine and sine being cos. So if we add up to 90 degrees in our angles and our trig ratios are cos and sine, then it means we are the same. I repeat, if our angles add up to 90, let's say there's the two of our trig ratios, our angles add up to 90 when we add them up, and our trig ratios, are respectively cos and sine, then it means those trig ratios are exactly the same. Let me show you what I mean. So for instance, do you see here, this cos 30, right, is the same thing as sine of 60. Why? What's 60 plus 30? That gives you 90. Look at the trig ratios. This one is cos, this one is sine. So these two are the same. Don't mind the sign. Obviously, they are the same as far as trig ratio, but it's just that the signs are different. Okay, that's what we mean by complementary co-function. Look at sine 55 and cos 35. Cos 35 and sine 55. What's 55 plus 35? It's 90. What's sine and cos? They are co-functions. So these are the same too. Look at this. Okay. 55 plus 35. That is what? 90. But look at the sine and cos. Those are co-functions. So we call these complementary co-functions. And we say complementary co-functions are the same trig ratio. Okay. So this is an important piece of knowledge that when you have it and you understand it, then you can use it in situations that need using it. Okay. Yeah. Very useful info, this one. Very, very useful. Okay, helps us out a lot in many situations and scenarios. Okay. It's just something to note. So when you simplify this, you can find that it's easy to simplify this thing. So for instance, this is this guy and this guy, complementary co-functions. So let me do this. We are going to say negative cos 30 times cos 35, okay, plus cos 30 times cos 35. This sine 60 and cos 30, they are the same. The signs are different. This cos 35 and this sine 55, they are the what? They are the same, because if you add the angles 55 and 35, they give you 90. And then these are co-functions. So you can write them as the same trig ratio, right? Then what do you notice? This is a negative of this plus a positive of that. What is a negative plus a positive of that? I hope you can see what you should be seeing, guys. I hope you can see what you should be seeing. I hope so, for your case, for your own sake. Okay. I hope you can see. Yeah, exactly. That will be 0. Now you know that 0 divided by anything doesn't matter what it is. 0 divided, in maths, 0 divided by anything is going to give us 0. Okay, so negative tan 30, for instance, this and that, I'll write as cos 35. And then negative cos 35. Okay. So if I say 0 divided by all of that information gives me a final answer of 0 anyways. Okay. Gives me a 0 anyways. Keep the value, brother. What's that? What does it even mean? Okay. Hope that makes sense, guys. So me, I wouldn't really waste my time too much. I know that 0 divided by anything gives me 0, because when there's a 0 in the numerator, no weapon formed against 0 can prosper. So I honestly wouldn't bother myself too much simplifying the denominator, to be honest. Get straight to the point. So yeah, but what was the point of that simplification? It was just to reveal certain other things that we need to be very much aware of. Okay, yeah, I just want to look at some identities. Hi, keep the value for the meaning. I wanted to understand that too. I don't know, maybe it's a brother from another country and he's basically giving me encouragement, saying keep up the good work. I appreciate it, brother. Thank you, brother. Prove the identity. Okay, let's look at one question. Okay, 1 minus tan theta sine theta cos theta is equal to cos squared theta. Guys, proving identities. Remember, proving identities is about taking a complex side. Okay? You identify the complex side, you take it, you simplify it until it looks like the less complicated side. Take complex side, simplify it until it looks like the less complex side. And sometimes you can do that, but then find that you get to a certain point and then you have to take the other side as well and simplify it, right? So here, for instance, you can see who's complex this side. So I'm going to say left hand side is equal to 1 minus tan theta sine theta cos theta. Then I'm going to simplify that. Now guys, let's remember some key identities that can be used. There's sine squared theta plus cos squared theta, which you need to know, which is equal to 1 in grade 11. Okay, very useful identity, that one, that the sum of the square of sine and cos is equal to 1. Okay, then obviously you can make sine the subject, 1 minus cos squared theta, cos squared the subject, you get 1 minus sine squared theta. And even when it comes down to it, difference of two squares, the factorization of the subject being sine squared theta, you can always open two brackets if the simplification needs you to. 1 minus cos squared theta can be expressed as 1 plus cos theta into 1 minus cos theta for the purpose of factorizing this to a difference of two squares. Likewise, with 1 minus sine squared theta, you can factorize difference of two squares. That's the first identity in grade 11 you learn. The other one says tan theta is equal to sine of theta over cos of theta. This is the other trig identity that is very beneficial and helpful, which you need to know, because oftentimes where tan theta is, you can substitute sine theta over cos theta so that you can then have the simplification happen seamlessly. So if we come to this problem, what can you see? You have 1 minus tan theta immediately. I am going to use my identity. Substitute in the place of tan theta, sine theta over cos theta. Multiply by sine theta. Let's reveal it. Sine theta over 1. Cos theta, we know most is cos theta over 1. Okay, BODMAS comes into play very nicely. You can never subtract whilst there's multiplication. Multiplication comes first, addition and subtraction comes later. So we can simplify here, okay, if it is feasible. Okay, so this cos theta and that cos theta will cancel. You are left with 1 and 1. Then you have 1 minus sine theta times sine theta in the numerator means sine squared theta. That's 1 minus sine squared theta. But what is 1 minus sine squared theta as per the identity? 1 minus sine squared theta can be written as, you can see. So you see, it's not enough to just know the identity, sum of the square of sine and cos being 1, but you need to also know, when I make sine squared theta the subject, what is the expression? When I make cos squared theta the subject, what is the expression? Because now I'm having to use this very expression to then substitute in the place of 1 minus sine squared theta what? Cos squared theta. And what is this? This is the right hand side, which is this here. So that's where you can conclude that LHS is equal to RHS. That's been proved. Okay. 2. Okay, let's go. Tan squared x cos squared x plus cos squared x is equal to 1. Okay. There's this strategy, guys, that they say you should use. It's simplify, factorize, identity. Simplify, factorize, identity. Okay. So we are constantly moving between these three things. SFI. Okay. Where there's addition and subtraction, factorization may need to be applied. Where there is an identity that needs to be substituted, we have to substitute the identity. So for instance here, we look at this, we're like, can we simplify this? No. Okay, is there any factorization that can be done? No. Then we move on to the last thing, identity. Boom, identity can be used. Tan theta, sine theta over cos theta. Then we, after using the identity, we go back. Simplification? Yes. So here, we started off by looking at the question and we were like, can we simplify? No. Can we factorize? No. Identity can be applied? Well, out of the two identities, yes, tan theta, identity. So identity is applied. I operates, and then after I operates, we're like, okay, let's go back. Can we simplify now? Yes. Okay, after simplifying, can we factorize now? No. Identity? Yes. So we are constantly jumping between simplifying, factorizing, and identity. And we just need to ask the question, what can we do now? You see, so when we, guys, so it's SFI, this one. I get SFI, guys, SFI. Okay, SFI. Okay, so let's go, come here now. Tan squared x, cos squared x, plus cos squared x. Okay, so we are here now. Tan squared x. Okay, can we simplify? No. Factorize. Well, we could factorize. Okay, the more complicated side is the left hand side, guys. Okay, we could factorize. Okay, we definitely could, right? But I'm sure you guys can see something else here. I see Seramit is like tan squared x can be written as sine squared x over cos squared x. Okay, that's going to be multiplied with sine I mean with cos squared x over 1 plus cos squared x over 1. Yeah, so obviously then that guy goes, we are left with sine squared x plus cos squared x. And what is that? Sine squared x plus cos squared x. That gives us still 1. So that is the left hand side is equal to 1, which is basically what? The right hand side. So therefore we conclude that left hand side is equal to right hand side. Proved. Okay. So that's very important, guys. That identity helps us out a lot. Is helping us out a lot there. Okay, so you see the incorporation of this identity. If you square the left hand side, you can also square the right hand side. Okay, that's another manifestation. It's the same identity, but it's just that reason why we could say sine squared x over cos squared x is because this is tan squared x. Okay, it applies. Okay. Right. Okay, I want to do one last identity type question. Okay. Yeah, for now. 1 over 1 minus cos theta plus 1 over 1 plus cos theta is equal to 2 over sine squared theta. Who's most complicated? Once again, left hand side is, we have what? The addition of two fractions. Guys, with the addition of two fractions, you can play the butterfly rule. If it's two fractions, guys, butterfly. But if it was more than two fractions, you just go ahead and use the LCD route. You find the LCD and so forth. But guys, if it's the two fractions, butterfly is easy, man. Step 1, take 1, you multiply by 1 plus cos x. So it's 1 into 1 plus cos theta. Please, guys, binomial in brackets, plus 2. 1, you multiply by 1 minus cos theta. 3, you multiply these two. Okay, makes life easy, man, when you have two fractions which you are adding or subtracting. Butterfly rule just is straightforward. I think it's really made for those that really want to get straight to the point. Then you distribute. That's 1 plus cos theta, 1 minus cos theta. Then obviously this one. For now, let's leave it as those two brackets. Okay. Then let's add the like terms. Remember, with addition of fractions, when the denominators are the same, you can add the numerators. 1 plus 1 is 2. I think Snoko has gotten us into that vibe with 1 plus 1 being 2. Okay. Then here, cos minus cos is 0. But down there in the denominator, I think since we have that sine squared theta, what we want to do is we actually want to multiply out. But you see, this is the reverse of a difference of two squares. Okay. 1 minus cos squared theta is what we would get after multiplying out. Because 1 times 1 will be 1, 1 times cos theta will be cos theta. Negative cos theta times 1 will be negative cos theta. And then negative cos theta times cos theta will be negative cos squared theta. The like terms in the middle will basically lead to 0. And then we'll have 1 minus cos squared theta. But remember, as per your identity, what's 1 minus cos squared theta can be expressed as sine squared theta. So we have 2 over sine squared theta. This is our right hand side, guys. So our left hand side is truly equal to our right hand side. No joke, no problem. Okay. So that was just an exposure to proving identities. Okay, just a bit of exposure. Otherwise, yeah, when I look at these types of problem now, if tan 35 degrees is equal to k, okay, I'm sure you've seen these problems. If tan 35 degrees is equal to k, write the following in terms of k. A, they say write tan 145 degrees. Okay, so let's see. What do we do in questions like this? In questions like this, guys, it's a matter of you can draw a, it's up to you. You can either draw a free-standing right angle triangle. Okay. RAT means right angle triangle. You can draw a freestanding right angle triangle, or you can use the first quadrant, because when they say tan 35 is equal to k, the assumption is that that is a positive. Okay, so it's up to you. Do you want to draw a freestanding, just a typical freestanding right angle triangle, or you can draw a triangle in the first quadrant? So let's look at this. Tan 35, that means we have an angle that is 35 degrees. What is the definition of tan? Tan is opposite over adjacent. So we are going to write k and write it as k over 1. Opposite is going to be the k, 1 is going to be the hypotenuse. Opposite, not hypotenuse, the adjacent side, my bad. Okay, remember, SOHCAHTOA, sine is opposite of hypotenuse, cos is adjacent of hypotenuse, and tan is opposite of adjacent. So it's tan 35, opposite over adjacent, opposite over adjacent. Okay, then let's make sure we have all angles and all sides. So 35 degrees is then 90. What's missing here? 90 degrees plus 35 degrees plus that angle that we want is equal to 180. We know it's the interior angles of a triangle. 125 degrees plus x is equal to 180. We have x is equal to 180 minus 125 degrees. So our x value, as you have said, is 55 degrees. That's our x value. We punch, or we pop that in there. After popping that in there, we can then go ahead and use our Pythagoras to find the missing side, because all we want here is all sides and angles to be represented. Okay, so Pythagoras is what we're going to use to find the side. So we're going to say r squared is equal to x squared plus y squared. We always write the reason. Pythagoras, when we do use it, r is what we want, x is 1, y is k. So 1 plus k squared. We take the square root on both sides. We put plus minus, but of course, for a freestanding, we know that the value of r will be positive, and we know anyways that r is always positive. Okay, so we have the square root of 1 plus k squared. 1k square root of 1 plus k squared. Okay, now we have all the angles for the right angle triangle. And we have all the sides. So now we can go and answer the questions that are relevant. Tan 145. In our triangle, we don't have 145. So that means we need to first take this tan and reduce it. 180 minus what will give us 145. Okay. Tan 180 minus 35. You see? So 180 minus 35, which quadrant? Second. How is tan? Tan is negative. Then in terms of k, we are going to go to the diagram and read where is 35 degrees. There is 35 degrees. Opposite over adjacent. So it's going to be negative k over 1, which is actually equal to negative k. That is tan 145. It's equal to negative k. You see, guys? So that's how we get the values. Okay. Next one. Tan to 15 degrees. So once again, tan to 15. Tan, we are going to say 180 plus what? 35 degrees. Okay. Reduction using an acute angle. That's appropriate to the diagram. 35 is there. So what do we say here? 180 plus is in the third quadrant. How is tan? Tan is positive. So we say tan 35. So that is k over 1. That is positive, which is actually equal to k. Okay, not a problem. We go to C. The next question. Tan of negative 325. What do we notice about the angle? The angle is a negative angle. It's greater, it's negative, and we need to have it be between the quadrants 0 to 360. So we can say negative 325. We add 360 until, yeah, there we go. We add 360 the first time round. We get tan 35 from the get-go, which is beautiful. Okay, angle now is between 0 to 360 when we add 360 the first time round. So then what do? We go to our triangle directly. Tan is k over 1, which is k. That is the angle in terms of k. That is the ratio in terms of k, sorry. The next, sine 35 degrees. What's sine 35? This one is already acute. The angle is in the triangle. So we go there. We say k over the square root of 1 plus k squared. K over the square root of 1 plus k squared. E, cos of 325. 325. Let's reduce this. Cos of 360 minus 35. Then 360 minus in the fourth quadrant, how is cos? Cos is positive. 35 degrees, we go there. Cos 35, adjacent over hypotenuse. That's 1 over the square root of 1 plus k squared. That's the answer. Okay, no problem there. Very straightforward, to the point, not asocolis. Okay. Yeah, guys, so that is your Pythagoras type. Pythagoras type. Pythagoras type. If you cry about Pythagoras type, you cry because you like crying. And when people like crying, there's nothing you can do about that crying, because they enjoy crying. Okay, I'm just gonna close this with the general solution and solving of equations. Okay, so I'm gonna close this with the solving of equations. General solution. Okay, let's start very basic. Sine theta is equal to root 2 over 2. First step, general solution, theta is equal to sine. Okay, now sorry, that's not the first step. When you are doing grade 11 general solution, The objective is to find a general solution that will basically accommodate any angle we want to find in any quadrant, whether that be within the 0 to 360 interval, or it can be beyond the 0 to 360 interval. So what we tend to do is we look at the trig ratio. If the trig ratio is isolated already and it's positive, then we ask ourselves, sine is positive in which quadrant? Okay, sine is positive in the first and second quadrant. Then we find something that we call the reference angle. RA, we call it the reference angle. Okay, reference angle is an acute angle, right? It's an acute angle that will basically help accommodate all of the quadrants, all right, were we to land in a certain quadrant in another revolution of our unit circle. Okay, so RA is equal to, we take the inverse of the sine function, or arcsine, root 2 over 2, and we get our reference angle. So you grab your calculator, you find your reference angle, you say shift sine, then it's saying root 2 over what? 2. You get a reference angle of 45 degrees. Remember, we had said, where is sine positive? Sine is positive in the first and second quadrant. Now, this angle that you have there, you are going to use as the subject of your general solution. Guys, whatever is here, you use as the subject. You see, just as you take the reference angle, whatever was here, whatever it is, you use as the subject of your general solution. Okay, and then first quadrant, we are going to write the general solution. Second quadrant, we are going to write the general solution. This is how it's going to be. The subject is theta equal to, for both your general solutions, your subject is theta. Now, you take the reference angle for your first quadrant, you add it to the multiple of 360. So k is the variable that we used to represent any multiple of 360, where k is an element of any integer value. Remember, integer values are positive and negative whole numbers. So if we stay in the first quadrant, it's going to be 1 times 360. If we stay in the first unit circle, all right, in the first revolution, if we want to extend the revolution and enter into the second revolution, we are going to multiply k by 2. Third revolution, we multiply k by 3. Fourth revolution, and so it goes. If you want to go back to your negative angles, you times by -1, times by -2, times by -3. That is basically entering into new zones of the angles that we would want in those quadrants, whatever the situation is. Okay, so we are going to say theta is equal to, the reference angle was 45 degrees plus k 360, where k is an element of integers. This is my first general solution. The general solution that basically is occupying the first quadrant, and that is for however many revolutions you want. So for instance, if I multiply 360 by 2, that's my second revolution. I get the same angle in that quadrant, in that interval. Okay, so various interval answers can actually be expressed using the general solution. Okay, that's very important. Then for your second quadrant, okay, we are going to say theta is equal to, now remember guys, in our second quadrant we have a function value which is 180 minus. So what we do is we say theta is equal to 180 minus the reference angle. In the first quadrant we couldn't say something minus. In the first quadrant, the angle is acute already. So whatever the acute angle is here is what we represent as our reference angle for the first quadrant. But in our second quadrant, we know that in the second quadrant, it's 180 minus. It's the 180 minus quadrant. So we say 180 minus the reference angle. Plus what? Plus K360, where K is an element of integers. So when we substitute, it's 180 minus 45 degrees plus K360 degrees, where K is an element of integers, and then we get 135 plus K360, where K is an element of integers. These guys are my two general solutions for sine theta root 2 over 2. Okay, this is a very important, kind of skill you need to know when they are asking you determine the general solution. These are your general solutions. The moment they specify, let's say they say where theta is an element of, and then maybe they say from negative 180 to 180, then that means that they want the specific values of theta that are falling within the interval of negative 180 to 180. But the way to that is the general solution. So first, finding your general solution will help set the tone. Then from there, if they specify that they want theta, the specific values of theta in this interval, then it is your priority then to go and say theta is an element. Then you can list the values of theta that fall between negative 180 and 80. How? We are going to substitute integer values, So for instance, if you substitute negative 1 in here, you're going to get negative 360 plus 45 doesn't give you a value that is negative that falls in this interval. So substituting negative 1, negative 2 is going to send you down further to, it's going to send you to negative values that are not even close here. So that means we are going to start at 0. 0 gives us 45. Okay, 45 is fine because it falls within negative 180 to 180. We substitute 1. 1 times 360 plus 45, that gives you a value that's not even in this interval. So that means 45 degrees is the only value we can get from this particular general solution. We come here, we do the same thing. And we're like, okay, negative 1. We substitute negative 1 is negative 360 plus 135. Guys, what's negative 360 plus 145? Does it give us a value between negative 180 and 180? No. So that means no, that's not going to work. What about if we substitute 0? Well, substituting 0 gives us 135 degrees. Okay, so that works. What about substituting 1? Substituting 2? So we only have two values, and that's 45 degrees and 135. These are the only values that qualify. You see, they are the only values that qualify in this interval. But you only answer this kind of question if it is asked, right? If they just say determine the general solutions, you end at your general solutions. But if they ask you for specific values of theta for that particular equation, then you need to substitute, integer values, right? And really use just, a little bit of logic to sort of like ascertain what integer values would be appropriate. Please, guys, when you write your general solution, it's important to write k as an element of integers. You could lose a mark if you don't write k as an element of integers for your final general solution statement. Okay, I think I need to do one last one and leave you guys in peace, or leave you guys in pieces. Determine the general solution here. 3 cos 3a is equal to negative 1. So first step, we want to isolate the trig ratio cos first. So what we do, divide by 3 both sides, we get cos 3a is equal to negative 1. over 3 when we divide both sides by 3. Now, this here needs to be kept, okay? But what do we see here? Cos is what? Negative. Cos is negative. Where is cos negative? In the second and third quadrant. Then what do? We ignore the negative sign. Okay, the minute we are able to say that cos is negative, the second and third quadrant, that is enough for us to be able to then ignore the negative sign and then find the reference angle for cos inverse of positive 1 over 3. We ignore the negative sign, guys. Some of you are going to be like, oh, but where's the negative sign? Ignore the negative sign because we already have determined where cos is negative in the second and the third quadrant. So for the purpose of the reference angle and us being obsessed with getting a acute angle, reference angle, we ignore that negative sign and we say the arc cos is of 1 over 3 is what? Grab your calculator. Shift arc cos 1 over 3, you get it at 70,52. Okay, yeah, so the reference angle is that 70,52877.937. okay, because we don't round off just yet. Okay, then remember we said cos is negative in which quadrant? The second and the third quadrant. So we say second quad, third quad. Subject, remember I said we make who the subject. Guys, whatever is here, yabo, is the subject. 3a is equal to, in the second quadrant, remember this is 180 minus, this one is the 180 plus, so say 180 minus the reference angle. Okay, all right, so I'm just going to, my goodness, okay, I'm going to place that there, 180 minus the reference angle plus k 360. Then what am I going to do? Where k is an element of integers. A divide by 3. We divide by 3 for all times. Everything, everyone. A is equal to. Okay, so let's do this. 180 minus, we put them brackets. Okay, 180 minus. Okay, let's do this. 180 minus, we put them brackets. We say shift cos of what? 1 over 3 over what? Over 3. 36,49. Round off to 2 decimal places. 36,49 degrees plus k 360 divided by 3. 360 divided by 3, that gives me 120. So that's k 120, where k is an element of integer. This, guys, is my general solution for second quadrant. Okay, third quadrant, make 3a. Remember, see, whatever is there, guys, if what was there was 3x minus 30, I would make 3x minus 30 the subject. If what was there was theta over 2 plus 10, I make theta over 2 plus 10 the subject of the general solution. Guys, whatever is there for the isolated trig ratio, you make the subject. I beg you, right? 3a is equal to, you have 180 plus, this time round in the third quadrant, cos of 1 over 3. We are going to divide by 3, so that means we also divide by 3 here. The k 360, we'd also divide by 3, where k is an element of integers. And we factor that in. A is equal to, let's come to our calculator, 180 plus, this time around 180 plus, we have cos, 180 plus shift, you have the cos 1 over 3 divide by 3. 83,51. 83,5. The 9 says what to 0? Divide by 1. 83,51. What? Degrees plus k 120, where k is an element of integers. Two general solutions. You see? Hi guys. Who wouldn't? Guys. You fail if you want. You fail because you want. Right? Yeah. I think tomorrow I'll basically look at more questions around this, because this was just me doing sort of like fundamental basics, right? There are those questions that basically, which have general solution where the trig ratios are the same, where you have to actually drop the base, and in that case you are working with sign. Where is sign positive? Because you can see sign both sides is positive. Where is sign positive? It's in the first and second quadrant. Then you work with the reference angle being equal to theta minus 80 degrees, you see, because in this case, so there's different dynamics. When trig ratios are the same, what do we do? When trig ratios are not the same, sine and cos, what do we do? When the sine and cos and the angles are the same, we divide both sides by sine. If the sine and cos, the angles are not the angles are the same, we divide by cos both sides so that we can form the tan ratio on its own. But there's cases where the angles, sine and cos are on either side, the angles are not the same. That's where we use the co-ratios so that we can make the trigonometric ratios the same. So I'm going to look at those dynamics and those intricacies in tomorrow's live. Unfortunately, I have to leave now. I can't really stay and do and treat all these other scenarios. But I hope this was very helpful. Okay. Some copy of your compiled questions. Where may I download? You're killing me here, Sehamed. This is extracted from a textbook. Alright, it's extracted from a textbook. These particular questions. So yeah, these are textbook questions. Because that's where you need to start fundamentally, from the textbook with those questions. The exam papers, remember, need you at least to have the basics down. So and these are taken from the textbook. I'm not using any particular resource, but just the textbook. There's a textbook called Mind Action Series, so I'm just taking from that textbook, and these questions are coming from there. All of these, okay, all of these questions I've been doing here are from the Mind Action Series textbook. So credit to them, because I've basically been doing the problems that are extracted from their textbook. Okay. All right, guys, I need to bounce. Have a good day. Thank you for joining in. It was good. You can watch that.